Intro to Solving Systems by Graphing. In this video, we will work through page 5 of your notes. Question number 1 says, what is a system of equations? A system of equations is two or more equations using the same variables that are graphed in the same coordinate plane. Number 2, what is the solution to system of equations? The solution is the xy ordered pair where the lines intersect. The xy ordered pair where the lines intersect. Okay, so here in this graph, say we had two lines graphed. Let's call this line 1, call this line 2. Where do these two lines intersect? Well, as you can see, where they cross at, they cross right here at this point. Okay, and so we need the xy ordered pair where that point is at. And so to get to this xy ordered pair, you start here where the x and y axis intersect, which is called the origin. And to get to this point, I would need to go right 1, which the x value would be 1, right? Right 1, and up 1. Right 1, up 1. And so the xy ordered pair is 1, 1. I go right 1, up 1, and that is the point where these two lines intersect. And so the point 1, 1 would be the solution to the system of equations of those two lines. Question 3 in your notes. What are the three methods to solve systems of equations? The three methods are, number 1, you can use graphing, and we'll learn about that in lesson 8.1. The second method is substitution, which we'll learn about in lesson 8.2. And the third method is elimination, which we'll learn about in lesson 8.3. Okay? Number 4 on your notes. When solving by graphing, what form must the equation be in? It must be in slope-intercept form. Slope-intercept form, which we've already learned, looks like this. Y equals mx plus b. And so essentially you're solving the equation for y. Y is on one side, everything else on the other. M, what does M represent? M represents slope, right? Slope. M, which is the number in front of the x term, that tells you your slope. What does B represent? Well, B represents the y, what? The y-intercept. The y-intercept. It's where it crosses the y-axis. Wherever the line crosses the y-axis, that is its y-intercept. Question number 5. When graphing an equation, you plot the y-intercept on the y-axis. The y-axis. Okay, number 6. What is slope? What is slope? We can answer this in at least 3 different ways. The first thing we could say about slope is it is the steepness of a line. How steep is the line? That is its slope. Number 2, we could say the slope is the ratio of the vertical change to the horizontal change. And the third way we could say it is slope is rise over run. And so rise, which means does from one point to the next point, are we going up or down? So if we're going up, that would be positive. If we're going down, that would be negative. So that is the rise, or we could say that is the vertical change. The vertical change is what does the rise of the line look like? The bottom number, the denominator, is the run, which means we're going right or left. If we go right, that's positive. If we go left, that is negative. And so just like the rise would be the ratio of the vertical change, the bottom would be the ratio of the horizontal change, the side-to-side change in the slope of the line. Okay, number 7 says use slope to plot 2 more points and then draw a line. Okay, you plot 2 points, and then connect those points with a line through the points. And then number 8, where the lines intersect, is the solution. To the system. Solution to the system. Okay, we'll do one example here. This comes from page 10, or number 10 on page 7. Number 10 on page 7. Let's say that we had this equation right here. You're given this graph, and you want to write the equation for this graph. First off, what is the B? What is the y-intercept? Where does this line cross the y-axis? Well, this right here is the x-axis, so we're not going to look on that line. This is the y-axis. Where does the line, in the purple line, where does it cross the y-axis? Well, as you can see, it crosses right there. That is where it crosses the y-axis. So what is that value? Well, right here, this is the origin, right? This is 0. And so to get to this point, I would need to go down 1, 2, 3. And so the b, or the y-intercept, is equal to -3, right? That is where it crosses the y-axis. Now, once you know the b, look for the m. How do you get from one point to the next point? Okay, well, let's say from here to here. From here to here, I would need to go up 1, 2, up 1, 2. Okay, so I'm rising 2. So m is equal to rise over run. I am rising 2. I'm going up 2, going up +2. And after I go up 2, I would go left. I would go left 1, 2. I go left 1, 2. And if I go left, that means I'm running or going left 2. So I'm going to put -2, because if I go left, that's negative, right? So my slope is 2 over -2. 2 over -2. Can I simplify that? Well, 2 over -2, or I could say 2 divided by -2, that's simply -1, right? So my slope is, my m is -1. So if b is -3 and m is -1, I now have the two values that I need to be able to write an equation in slope-intercept form. Because I know slope-intercept form is y equals mx plus b, I can write this equation as y equals m. What's m? -1. Y equals -1 x plus b. And what's b? -3. So I could write plus -3, but all I really need is -3 or -3. And so this right here, y equals -1x minus 3, this is the equation in slope-intercept form for this line that was given to me. And again, that is number 10 on page 7 of your binder. Okay, you write the equation for this line. Okay, now back to your notes. Number 9, there are 3 possible solutions to a system. There are 3 possible solutions. The first possible solution is you could have one solution. You could have one solution, which means there's only one order pair that works in both equations. This is created by intersecting lines. It's created by intersecting lines. So the lines cross. They cross at some point, and the point that they cross at, that is your solution to the system. In fact, this is the only order pair that satisfies both equations. I also want you to write over here, if the equations have different slopes, if the equations that you're looking at in the system have different slopes, that means there is only one solution. One solution. So if you're looking at the equations of the lines and they have different slopes, you can tell right away there's going to be only one solution, only one order pair that works in both of the equations. So you could have one solution. You could also have no solutions to the system. And in this case, there would be no order pair that works in both equations. This is created by parallel lines. So if they're parallel, there is no point of intersection. The lines will never ever cross. And if they never ever cross, that means there's no point that they intersect, and therefore no solution. Parallel lines have the same slope. They have the same slope with different y-intercepts. Okay, so the slopes are the same, but their y-intercepts are different. So you could have one solution, no solution, or infinitely many solutions. You could have infinitely many solutions. This would be the case when you have an infinite number of order pairs that work in both equations. This is created by identical lines. The lines are the same. They're the exact same. They're identical. They lie on top of one another. The lines are actually intersecting at every single point on the line. These lines have same slope. They have same slope and also the same y-intercept because they are the exact same line. And so therefore, they intersect at every single point on the line, which means there are infinitely many solutions. Number 10, what are the 4 kinds of slope? There are 4 kinds of slope. You could have positive slope, you could have negative slope, you can have zero slope, and you can have what is called undefined slope. Undefined slope. Okay, number 11, what does positive slope look like? In general, the slope will be going upwards, right? The line, as read from left to right, like you read a book, as read from left to right, as you can see, this line is going uphill, right? If I start here, if I draw a little guy and he walks this line, he will be walking uphill. And so that generally is what positive slope looks like. Number 12, what does negative slope look like? Well, it's going to be going downhill, right? As read from left to right. If you have a guy right here and he's walking, he will be walking on that line downhill. And so therefore, negative slope looks like a line that's going downhill. Number 3, what does zero slope look like? Zero slope is when you have a horizontal. You have a horizontal line, which is a side-to-side line. A line that is side-to-side will have zero slope. So anything that says like y equals 2 or y equals 4, if you have an equation that says y equals some number, that is going to produce a horizontal line. This means that all of the y values are 2 or all of the y values are 4. This is zero slope. A way that I like to remember this has zero slope is if you take this horizontal line and draw a z, z for 0, right? Z for 0. It has zero slope. And then finally, number 14, what does undefined slope look like? Well, undefined slope is when you have a vertical line, which is an up and down line, a straight up and down line. And so anything with the equation like x equals 5 or x equals negative 6. If x equals some number, that equation will produce a vertical line because all of the x values would be 5 or all of the x values would be negative 6. And so a way to remember that this line has undefined slope, or we could say no slope, it has no slope. Sometimes you'll see it like that, no slope. The vertical line, we can make an N. We can make an N like this, no slope. It has no slope. Okay, so those are the notes for page 5 in your binder.